In previous lessons, we've looked at data blocks from the sort of view angle of instance data blocks, which is the association of data with a function block instance. And we're seeing this here again, calculations DB, and this is an example of being tied to an instance of this function block. But we can also just create data blocks that aren't associated to anything or are just associated to data types. And we can do that by clicking Add New Block and coming to Data Block. So in this list here, we have all of the different types of data blocks that we can create. So a global DB, which simply means it's not tied to any type of data. You're free to put whatever you want in it, and it's also accessible from anywhere in the project, although so are instance data blocks. And then down here we have an array data block, which is exactly the same as the global DB, except for you can also define how many instances in an array or how many elements in an array you want to also create. And then we can also define instance data. So if I wanted to, I could create a new instance of calculations of the FB, and that would provide me with the interface as well. And then also some data types where you can define, I want to create a data block, but I want it to be tied specifically to this type of data. So for now, we're going to create a global DB, and I'm going to click OK, and we'll see the difference between what it creates and what we've seen so far. So if I go and have a look at the calculations DB, I can see that we have static data, but we also have in-out, output, and input. And our input, output, and in-out make up our interface. But for a global DB, we don't need an interface because we're only working with data. So we only end up with a static, which is just the internals for the data block. So if I write in here, enable, create it as a Boolean, and then I can then reference that on here. So if I type in data block 1, there's enable, and we now have tied the system enabled input to these variable in our data block 1. If I come inside the data block, I can also reference data block 1 here. So just remember that DBs, so pretty much anything with this DB symbol here for a data block, is accessible from anywhere in your project. Much later in the course, we'll come on to why it's not a good idea to just put everything in data blocks and access them from anywhere in your project. That's not a good sort of thing to get into. It causes lots of issues later when we start working with libraries, but it is something that we can do. And it's especially useful in top level function blocks to keep things organized and things like that. So let's have a look at what we can actually do inside a data block. So let's look at the columns to begin with. We have our name, which is the variable name. We have data type, which is the data type. The start value, what we want the data to actually contain the first time the block is interacted with. So just imagine we're downloading this data block into a PLC. The PLC's never seen it before. What do we want the data to be? If I set this to true, then the first time the PLC executes and runs or reads from this data block, it will read true on this enable variable. We can click retain, which is retain the information between power cycles. So if the PLC gets turned off, when it comes back on, it will remember what the last known value was. Under certain circumstances, when it can't retain the value, because that does happen, it will use the start value. This column here, which is accessible from HMI or OPC UA. If this is not checked, it's checked by default, but if it's not checked, then you won't be able to read this value from a HMI or from the OPC server. This one here, I don't know why they make these columns so small, but this one here, writable from HMI, can we write to it? So you could make it read only, so the HMI can read the value, but is not able to write to it. And this one here, visible in HMI engineering. Can the HMI see that this tag exists? In nearly all circumstances, it's safe to just leave these turned on. But for some sort of setups where you might have a DB that is used for configuration of the system that you only set once and you don't want anybody to be able to access that information once it's set, turning these off is the sort of way to do that. And then finally, for checkboxes, we have set points. Now, with this ticked, this doesn't actually serve any purpose other than giving you some extra flexibility around reloading data to a live PLC. And we'll come on to that later, but effectively using snapshots, these options up here where we can snapshot data, copy snapshots to start values and load start values as actual values, you can filter that to just set points only, which keeps your runtime data for things like sequences and things that you wouldn't want to update without going through a logical path. It keeps those safe from updating things like set points, which potentially aren't dangerous to change during execution of the PLC project. And you also have comment. And we'll come on to supervision because supervision is something in its own sort of section. It's all to do with ProDiag and central alarm management and not something that we're going to cover at this early stage. But what we're able to do in data blocks is manipulate these options here to change the way our data is used. So let's add some more things into our data block and have a look at sort of like a typical use case. So right now we have an enable signal. Let's have a target variable, which we'll set as a real. And then let's have a result, which we'll put as a structure. We'll put as a struct here. And what this does is give us an inner element that allows us to add more variables and they will reside within this structure. So this is a loose structure and the structure is only known to this particular data block. So it's not a user defined type. It's just a structure that's done on the fly. So I'm going to call this R1, real, R2, and R3. And you'll notice that I only had to define the real once, and then the next variable that I created adopted the previous variable's data type. Useful, but also can catch you out if you're not paying attention when it automatically selects the data type that you used previously. You'll notice as well that for structs or structures, I'm not able to tick the set point button, but I can tick it for inner elements. And you'll also notice that I can tick it for retain, but I can't tick it individually for inner elements. So if I retain the structure, you must retain everything within it. And again, this sort of information is useful to know because it's really easy to catch you out when you're setting stuff up. So let's have a look at how we can use this now. If I come into main, I've already updated our system enabled to use data block 1. And in here, I'll now use data block 1 and change it to target. And that's going to pass the target information into our calculations function block. And something else that I want to show you, if I now go ahead and rename this to config, for example, actually, I'll call it test. You can see that it's changed the name here, and also any references towards it have also been changed. If we come into calculations, where we have system 1 calculations output, I could then change this to test result R1, and I can copy these down and change them to R2 and to R3. And then when we run our system, anything that comes from system 1 calculations will be put into test. And obviously we're using the information from test on our system enabled and data because we're coming from our main OB layer, which is already referencing those. And our function block for the system 2 calculations is still putting stuff in the instance data. So we're clearly using global data for test and the information coming from function block 1, but we're still using the calculations DB for function block or system 2, these ones here. So we're ending up with information in two places, but how we're using that information is important to understand. So something that I want to show you is if I come into test now, our information is structured like this, and it has nothing to do with our function blocks. However, if I come into function block 1 and I decide in later revisions of this that actually I now want to add a new input that gives me a average time delay, and this is going to be a time field. And I also want an additional output that says delay active. What we'll see is in our calculations DB, once I right click and go to update interface, that this information has been updated and the length and size of this calculations DB has grown. We've added more information into our function block, and therefore this calculations DB has had to grow. In our test data block, though, nothing's changed because we're moving the information into a dedicated place that we might interact with SCADA, we might interact with some other HMI vendor that's not Siemens. And something that's worth noting is that internal addressing, where the memory is actually kept, may change because of the actions that we've taken in function block 1. So in this calculations DB, the structure has changed, but in test, which is our global DB, nothing has changed. And that is an important difference to understand, because anybody who's worked with much older systems, which are absolutely addressed, where you actually address the memory location directly as opposed to a symbol, what we've just done in calculations DB would change the addressing, which would break everything on a HMI or SCADA system or anything else that is referencing this information. And that is a really easy way to cause problems. So I always recommend that your final endpoint for data before you use it anywhere outside of the PLC should always be a global data block. That way you save yourself a lot of headaches. But again, more of this stuff will become apparent as we go through the course. So let's have a look at adding an array DB, because arrays are really useful, and where possible, we should try to create arrays. There's two real different ways of doing this, and personally, I don't use the array DB. I would tend to create an array in the global DB, but I just want to show how this works. And I might have said earlier in this lesson that an array DB works exactly the same way as a global DB. It does, but I'm wrong in what I've said there. I should have said that you can create an array of a data type, and if you're using a UDT, which is what we'll come on to in the next lesson, you can make it work the same way as a global DB by defining a user-defined type. However, normal circumstances, you would declare a basic data type, such as real. So we'll create it as a real, and we'll say we want 0 to 1, an array of 0 to 1, which has 2 elements. And when I click OK, let me just quickly change the name, because we'll have call this test array. This will create a array data type with real in it, and you'll notice that we can't change it. It's defined explicitly during creation and is not available to be changed. If I expand this, you'll also notice that I cannot retain this data type, and I cannot set it as a set point, which is somewhat restrictive. I'm not quite sure why we can't do that in Siemens, but you're unable to do it. However, it has done what we've asked it to do, which is to create a global array data type of 0 to 1 for real. And we can access that the same way that we can access any other data type, any other data block rather. However, the way I would do it is if we wanted a test array, I could put in here test array and define it exactly the same way. Array 0 to 1 of real. And then when I drop this down, I get exactly the same thing. So in here we have test array 0 to 1 of real. And now here I have test array 0 to 1 of real, but I can retain it. And I can also set it and its internals as set points. So not quite sure what the mechanisms behind the scenes are there as to why we're not able to do it when it's defined as a global array. But personally, because I make use of retain a set point quite extensively, I would always define it in a global DB this way. So little subtlety there that's worth knowing. That really covers the basics of DBs, and I really want to stress that this might not make sense to people who are brand new to the Siemens environment or the TIA Portal environment, especially if you've come from other vendors that don't make use of data blocks and have things like tag tables or like Alan Bradley's sort of just everything's in controller tags, that sort of setup. But it will make sense as we go through the course, and there is real merit to using data blocks, and I encourage anybody who's trying to find their design pattern or their way of putting projects together, I encourage you to use data blocks instead of M registers, instead of working globally with inputs and outputs and the tags directly. Always try to move them into data blocks.